So continuing chapter 11, working with powers and polynomials, this is going to be question 15. So question 15 says, identify the degree of each term of a polynomial. So when I talk about terms, one of the easiest things to do to see terms is, one thing is, so a term is a number, a variable, or product of number and variables, of a number and variables. So it can be a number, a variable, or a product, which means a multiplication of a number and variables. The degree of the term, it's the exponent of a single variable term, or it's the sum of the exponents of a multivariable term. Now, notice that also terms are separated by addition or subtraction. So if we look at this example, this is described as a three-termed expression. So this is a trinomial. And to see the terms, what I use is a circle. So I circled the first term. When I circle the second term, I include the subtraction symbol with it. And when I circle the third term, I include the addition symbol with it. So when I do this, I'm really rewriting this as 9x squared plus a negative 3x plus a 9, if you will. So, but I'm doing that in my head. So when I see these circles, I'm actually using the word and here. 9x squared and a negative 3x and a 9, because ands imply addition. So what I'm seeing is there's a 9x squared, a negative 3x, and a 9. So now it wants us to identify the degree of each term. So the first term is this 9x squared. Its degree is the exponent of the variable. So since x is the variable, the 2 is the exponent, the degree of 9x squared is simply the 2. So the degree is the exponent of the variable part. So if I see negative 3x, notice how the variable is x, but remember, when you have an x, that means there's one x present. So the degree there is actually a 1. And we've talked about this a little bit. 9, notice how there's no variable, but what we really have is 9x to the 0. 9x to 0 is the same thing as 9, because if you recall, anything to the 0 power is equal to 1. I think we define it sometimes as a to the 0 equals 1, but x to 0 equals 1 is the same concept. So if a variable is raised to the power 0 equals 1, or again, it can be a number as well. Keep that in mind that even 2 to the 0 is 1. So in our example, the variable is x, but its exponent is actually 0. So if you see a constant, if you don't see a variable, that means its degree is actually 0, because the exponent was there, but since its exponent is 0, it turns it into a 1 and makes it drop back out of the equation. So keep that in mind. So the degree of a constant is going to simply be 0.